I want to start by kind of introducing you to a framework in which to solve problems. Some of you are going to have absolutely no difficulty at this at the beginning, and then suddenly you're going to hit a wall. That's because some of you are very good at following procedures, and when the procedure breaks down, you have difficulty. So I'm going to give you a procedure, and then suddenly the procedure will break down, and that's when I need you to start doing the thinking. Got it? So let me start with a quick, straightforward example. All right. Very simple question, one that is in line with what you've already done. No difficulty, I don't think, in probably executing on this. However, I don't want to do graphing. I want to show you that you have another way to do this. We have derived 5 relationships from dealing with graphing. You can use those relationships. And you can use them somewhat blindly, meaning you can use them probably without thinking too much about what they do. I want you to start by realizing that every single problem that we have regarding kinematics boils down to 5 motion variables. And you have at your disposal 5 motion relationships. You have a permutation of 4 motion variables taken 4 at a time, which produces 5 equations. Basically, there's 1 equation for every 4 groups of numbers, which means most of the time, there's a 1 single step solution. Consider, this problem tells you that the car started at 30 meters per second, finished at 10 meters per second, and took 5 seconds to do so. These problems all have to give you 3 pieces of information in order for you to solve them. Of course, this left 2 unknowns. If you're interested in finding the answer and recognize that there's 2 unknowns, what you have to do is find a relationship that groups together the 4 interested pieces of information, the 1 unknown and the 3 givens. For example, say you want to figure out what the displacement is. Well, there is probably a relationship that will bring together these 4 pieces of information. Not a surprise, that relationship is one that we've already discussed. And it should solve your problem in a single step. Good? Not a problem, right? Now, I chose this one because I also know this one corresponds to area and slope. But I want to give you a procedure. So this next thing is for you guys who don't want to think very much. And I know you're out there. So if that's you, relish in that being the person you want to be. Because there's a way to do these without doing any thinking. You have to follow a procedure. And I'm assuming right now you did what I asked, and you have all 5 equations sitting in front of you on a note card. And they are organized in the manner in which I organized them on the board, with each equation settled next to one of the motion variables. Basically, I have an equation that's next to the motion variable that's not in that equation. So if you don't want to think very much, here's what you do. Let's say I want to find the acceleration. And I want to do so without knowing the displacement. You're given 3 pieces. You're looking for a 4th. So put a question mark in the thing you're looking to find and an X in the thing you don't have and don't need. Whatever equation is next to the X, that's the one to use. It will bring together the 4 pieces of information that you need that will solve this in a single step. Again, you'll be able to solve these problems without thinking. They're not particularly interesting, and it's not even a particularly interesting method. But if you want to think and you want to just plug and chug, this will solve exercises. Now, I keep using that word exercises because exercises don't really stress you very much. They are an exercise. By design, they're simply seeing if you can look at the relationship and execute the relationship. There's not much to do here. Let's try again, and let's see if this time you guys can take a little bit more handle of it. Let's try something more complicated. There you go. My suspicions are, with a simple procedure, you should, in one step, be able to solve each of these 2 questions. There are 2 questions here. I have a car that starts from some initial speed, slows to 10 meters per second over a distance of 100 meters with an acceleration of 2 meters per second squared. What was the car's initial speed and how long did it take? So there are 2 unknowns. If you wish to solve this, identify the given information, pick one unknown to solve for, and use the other unknown as your means of finding the most efficient relationship. I'll give you guys a moment. Now, this problem does require some context clues in order for you to be successful. I indicated that the final velocity was 10 meters per second. I also indicated that the car traveled 100 meters. Whether intentionally or unintentionally, I made those numbers positive. But the question emphasized the word slow. You might need to interpret that. If you have decided that 100 meters and 10 meters per second are positive, and the car is traveling in a positive direction, the only way it could slow is if the acceleration were negative. It would have to oppose the direction of motion. Might not seem like much, but if you're trying to figure out the initial velocity, you might have decided to eliminate and not use time, which would have chosen for you this relationship. Not a huge deal, except that I need to be careful about direction. You see, the problem with this, using this relationship, is it squares the velocities, taking away their directional information. And then at the end takes the square root, which means you don't know the direction of your answer. That's what a square root does. Now, that's not a huge problem until you realize that if you weren't careful, this side, which is 2 times 100, 200 times negative 2 is negative 400, equals 100 minus v naught squared. If you had not had a negative 2 there, and you had 400, when you subtract the 100, you would have gotten 300, and then you would have had to multiply both sides by negative, and you would have had to take the square root of a negative number. I promise, if you have to take the square root of a negative number, you've screwed a sign up. You should go back and look. You've made a mistake. That's one of the easiest ways to figure out you've made a mistake, is you being forced to take the square root of a negative number. We don't have imaginary numbers as answers here. Our problems exist in the real world, and therefore they will have real solutions. So that is a sign. And I'm telling you, write that down. You will not be taking a square root of a negative number. You've made a mistake, or I have. Now this tells me that the initial velocity is plus or minus the square root of 500 meters, square root of 500, which is about, what, 22.3? Don't throw away the plus or minus. Be intentional. This equation can't tell you the direction of your answer. You need to know it from context. Now, the answer is positive. In this case, the car had to be going a positive 22.3 meters per second so that the negative 2 meters per second squared could slow it down to 10. Makes reasonable sense. But we'll see some examples where this isn't true. Now, how many of you went on to solve for the velocity, solve for the time? Good. How many of you went on to solve for the time without using 22.3? That's what you should do, even if it's painful. And this one is painful. You should do it anyways. If you don't understand why it's painful, try it. Reverse this real quick. Indicate that you're looking for the time and don't use initial velocity. Be intentional. You'll see why. So you chose a relationship. You applied your variables. And you realize you have a quadratic. If you're paying attention, that's what you should realize. That now, first, we don't have to do it this way. You solved for the initial velocity. You could choose an easier way out. We could choose v equals at plus v naught. This would be an easier way out. All right? 10 equals negative 2t plus 22.3. T is certainly about 6 seconds. That is an easier way out. But this assumes you got this answer correct. And also, I'm sometimes not going to give you the option. Sometimes there might not be another way to do this. Don't be scared of this. You've been taught ways to deal with this for years. You could factor it. This one doesn't factor. But maybe you could factor. If you can't factor, you could always complete the square. But I always chuckle when I say that because nobody remembers how to complete the square. You do? There's always one or two. Good job. Be that person. Of course, you could always complete the square once and do it for every problem. We call that the quadratic formula, which I'm sure you all know. The whole negative b plus or minus the square root of b squared minus 4 times a times c. Oops. all divided by what? 2a. Here we go. I bet that will solve the problem. And not surprising, when you do this, negative 10 plus or minus the square root of 500 divided by 2. Exactly what you would have gotten over here. To the letter. Square root of 500, 22.3. 10 plus 22.3 divided by 2 is exactly how you get 6. We also get a negative answer. Is the negative answer the right one? I don't like to use the word never. But no, we generally throw away the negative time. Because negative time refers to a period outside of our observable window. But yeah, time's never negative. Now, everybody good so far? These are exercises. I had one enterprise say, why would we ever use quadratic if we can just plug in? I'm going to show you. Okay? You don't have to use quadratic formula here. You can find another way. Just be careful. All right. So you roll a ball up a ramp at 5 meters per second. Your friend is 3 meters away. The ramp causes an acceleration of 1.5 meters per second squared down the ramp. When does the ball reach your friend? Give it a shot. I think you guys are super. Yeah. I couldn't hear you. Well, if I want the ball to pass them, I think it seems obvious that they must be up the ramp away from me, but it may not be. They could be down the ramp behind me. So I'll specify they're up the ramp away from me. In that, I was not trying to be in any way, deceitful. In fact, I'd go on to say they are 3 meters away. The initial velocity ball, 5 meters per second. Acceleration, negative 1.5 meters per second squared. I'm not trying to be deceitful. That's the information you've been given. The acceleration is down the ramp. You rolled the ball up the ramp, so you should make the acceleration in the opposite direction of the direction of the ball. All reasonable assumptions. And you could make this negative, but that's not the answer I was going for. Now, I want you to find out when the ball makes it to your friend. If you've done this correctly, you know why it's tricky. Let's assume you don't find the final velocity. And I'd encourage you not to for a moment. Then you have delta x equals 1/2 a t squared plus v naught times t, which 3 equals 1/2 times negative 1.5 t squared plus 5t. 0 equals negative 0.75 t squared plus 5t minus 3. How many of you are quadratic formulating this thing? That's probably a way to go. Sounds like a bunch of you aren't doing this, but I haven't done anything weird yet, have I? Exact same thing we've been doing the whole time? I'd probably go ahead and use quadratic formula. But I told you there's more than one way to do this. You don't have to use the quadratic formula. But let's say -5 plus or minus the square root of 5 squared minus 4a c divided by 2a. -5 plus or minus a square root of 25. 0.75 is 3/4. So that's all just 9. -9, by the way. Divided by 2 times 0.75 is -1.5. 25 minus 9 is 16. You could have factored this. This comes out perfect. Square root of 16 is 4. So this is -5 plus or minus 4 over -1.5. Two answers. Let's see, -9 divided by -1.5, and let's see, -1 divided by 1.5. Both of those answers, I'm sorry, divided by -1.5. Both of those answers are positive, right? That's because the ball passes your friend on the way up and then again on the way down. There's two positive answers. Both of them are right. I don't know if your friend caught the ball or not. You have to interpret why there's two positive answers. Now, worse, let's say you tried to bypass this by solving for the velocity first. Stick with me for this one. You would have used 2a delta x equals v squared minus v naught squared. The one that does not have time in it because you didn't have the time, which is your only other option. This would successfully give you the velocity when the ball makes it to the person. But to do that, you would have had to have taken the square root of a number. Would you have remembered to take the plus and minus root of the number? Because the ball could be either. It will have one velocity on the way up and the opposite velocity on the way down. To find both times, you'd have to use both velocities, which is why I've told you, don't be complacent about taking square roots. You don't know what answer is correct. In this case, both of them were. Now, I'm going to stop here. You should write some of those things down because you will forget.